Good morning, everybody, and thank you for coming to attend this series of lectures. I would like to zoom in some of the questions that were already entertained by the previous speaker by looking at this issue of development of our species within Europe. So if you look at this tree of what paleontologists call species for hominins in the last, say, million years, you see that if we move back in time, say 300 or 400,000 years ago, we have an incredible diversity of hominins that existed, that's represented. And about 40,000 years ago, we have a dramatic change with only one species being represented. It's here, this orange bar. And you see this bar is the only one reaching present time. It's our species, Homo sapiens. And so there is, in the course of human evolution, in the course of hominin evolution, probably something we can see as the most important event in the course of the last million years is this replacement of all this diversity by only one form of humans. And there are many questions about why this happened. I won't enter this discussion today, but also about how this happened. And probably Europe is one of the few places, if not the only one, where we can really try to understand what is the mechanism of this replacement. And why we can do that in Europe, because Europe is the continent where paleoanthropology and prehistoric archaeology were born in the 19th century. And so we have an incredibly detailed record of this time period, say between 45 and 40,000 years ago, where this replacement took place. Maybe that is a too optimistic view of the situation, because if we look really at what we have, in this time period we have in Europe a variety of what archaeologists call lithic assemblages or technocomplexes, which are basically sets of stone tools which have a certain morphology, a certain type of techniques to produce them. And we tend to consider these assemblages as proxies for population, some kind of ethno-linguistic unities, or maybe some kind of biological entities. But the reality is that for most of these assemblages, we don't have the makers. We don't know who make them, because we don't have much fossils. There are a few exceptions that I'm going to mention. And of course, this is quite frustrating. This replacement of the Neanderthals by modern humans, it's something which is parallel to a main change in the technologies that humans were using. Neanderthals are associated with what Paleolithic archaeologists call Middle Paleolithic or Mousterian. And modern humans, after 40,000, are associated with something we call Upper Paleolithic. This Upper Paleolithic display a number of innovations in terms of technology, but also the development, for example, of figurative art. And we think there are many other changes in other domains of human behavior in this time period. So all these technocomplexes, assemblages that I showed you before, they are sandwiched between these two time periods, and they display sometimes features more reminiscent from the Middle Paleolithic, sometimes more from the Upper Paleolithic. And the tendency has been to treat all these so-called transitional assemblages in a rather binary way. What I mean is that all the Middle Paleolithic assemblages that we have in Europe have been produced by Neanderthals. We never found anything else but Neanderthals in this kind of sites. And everything that post-date, say, 40,000 Upper Paleolithic is produced by modern humans. And many authors have tried to assign transitional assemblages to one or the other. But we know that, in fact, during this time period, the replacement is not a real replacement. It has been called a leaky replacement with some level of gene flow between all these groups. There are a number of papers showing that hybridization took place between Neanderthals and modern humans, and non-African present-day humans carry about 2% of Neanderthal DNA in average. And in this time period, we have in Europe even examples of individuals that had a much higher contribution from the Neanderthal genome. This is one very well-known example, the mandible coming from a site in Romania. And this very individual has about 6 to 9% of its genome derived from Neanderthals, which implies that this individual had a Neanderthal ancestor somewhere like between 4 and 6 generations between the time it lived. So this is really an example of modern human coming into Europe and being in contact with Neanderthals and interbreeding with them. So there is a real possibility that some of the transitional assemblages that I showed you were produced by hybrids or were produced by mixed population. And this is the kind of question, of course, that we would like to, excuse me, I'm going to remove that, this kind of question that we would like to resolve. So what about the time overlap between Neanderthals and modern humans during this time period? So let's look first at the latest Neanderthal that we know in Europe. They are associated with an assemblage that is called Châtelperronien. It's found in center France and northern Spain. And this Châtelperronien, in fact, is a very Upper Paleolithic looking assemblage. You see here some of the stone tools, small bladlets that these people were making, and also bone tools, pendants, which is something which is almost completely unknown in the world of the Neanderthals before this transition period. And in 2 sites in Europe, Neanderthal remains have been found in association with the Châtelperronien, which has fueled a lot of discussion about the real association of Neanderthals with this assemblage. In the 2 cases, people have argued that, in fact, these Neanderthal remains are intrusive in these archaeological layers, and that Neanderthals did not really produce these assemblages. The skull that you see on the left side is probably the best preserved fossil hominin that we have from this time period, and we clearly see it's a Neanderthal. It has many morphological features of Neanderthal. I show you this specimen not just because it's a very nicely preserved fossil, but also to tell you that, in fact, this specimen was found now almost half a century ago, and that since this discovery, nothing like that has been ever found again in Europe. And so the problem we are facing is that when we try to address these questions about who produced what, we are facing, in fact, a great scarcity of the fossil material. And this is especially visible when we address the other question, which is what is the time and the nature of the earliest modern humans, modern Homo sapiens in Europe. These specimens for a long time have been considered to be dating beyond 42,000. And one was found in the UK, Kent's Cavern. And the other one, these two deciduous teeth on the right, come from an Italian site. What's interesting with these two specimens is that, well, first of all, it shows you the very fragmentary nature of this kind of material. Second, in both cases, it was impossible to directly date these specimens. And so what has been dated or modeled is there, in terms of chronology, is there archaeological context. And in fact, because these discoveries took place a long time ago, there is, again, always ground for discussion about the real age of this individual. So in order to solve these kind of issues, in the past of the couple of years, we developed another approach. And this other approach involves the study of something which is much less spectacular than these nice fossils that I show you. And these fragments of bone that are found by tens of thousands in archaeological sites of this time period. In fact, in most archaeological sites of the late Middle Paleolithic or early Upper Paleolithic, about 70 to 80% of the mass of bones produced by the sites are looking like this. They are fragments of shafts of bones which are morphologically impossible to identify. And to tell the truth, in past, they were just thrown away. Luckily, sometimes they were put in bags and stored in the basement of some museums. And some years ago, a group from University of York developed a method that recently became very popular, which is known as zooarchaeology by mass spectrometry analysis. Zooms, it's not the zoom we are using now, but another zooms. And this method takes advantage from the fact that collagen is a protein that survives very long in fossil bones, much longer than DNA. And it's possible to implement a technique to determine the species, or at least the genus, to which these fragments belong for a cost that is much lower and with a rapidity that's unparalleled with what would be possible, in theory, using paleogenetic methods. In theory, if DNA would be preserved, we could test all these little shafts of bone to try to identify to what species they belong, but that would be extremely difficult practically. But with zooms, in fact, what is done is that fibers of collagen type 1 are fragmented using an enzyme, here a trypsin, but there are other enzymes that can be used. And this produces peptides that can be, of which the mass can be measured by mass spectrometry. And among mammals, like the one humans hunted, there are little variations in terms of the amino acid sequence along these collagen fibers, but these differences are enough to be able to differentiate different species of mammals, or at least some to differentiate genus, as it's seen. And the method has been used increasingly for different things. First of all, to do zooarchaeology, to identify the fauna coming from the sites. Here you have a study that has been published last year by one of our PhD candidates. And what you see is the analysis of the faunal assemblages of two archaeological layers, one from final Mousterian, one from the transitional assemblage in a site in Italy. And these columns show you the composition in terms of species of what is found in these layers using morphology or using this technique. And you see that there are rather dramatic differences, and these dramatic differences tell us something about the behavior of humans. So in other words, a species that is almost not represented in terms of well-preserved bones can be very abundant when we look at the fragments, which of course implies a specific behavior by these humans. But this method can also be used to identify hominins in the bone assemblage among all these fragments. And in the past few years, we have conducted studies of this kind in several sites of this time period. And out of 5 sites where we conducted this kind of studies, we were able to identify hominins in this assemblage. Hominins that were invisible from a morphological point of view. So the first site is a site which is a Chateaubriand site that was already known for having yielded some human remains identified by, as Neanderthals. The problem with this site, Arcy-sur-Cure, or known as Grotte du Renne in France, is that again, because the excavation was very old, there was a lot of debates about the real association of these Neanderthals and the Chateaubriand, and it has never been possible to date directly these Neanderthals or to extract DNA, for example, to identify them. And so by conducting an exploration of the fragmentary material coming from a layer and an area of the site where hominins has been found already, we were able to identify fragments. They are really poor things. Most of these fragments are less than 1 centimeter. And all these little fragments, we know that they are humans. And from this point, it is possible, having this kind of little collection, to dispatch the material to specialists of isotopes, specialists of paleogenetics, and people doing direct dating. And so these fragments were identified as remains of Neanderthals by my colleagues, paleogeneticists, who were able to extract mitochondrial DNA. And importantly, it was possible to directly date one of them. And the date we obtain, it's a date that fits exactly in the time range of the Chateaubriand, so it's a clear confirmation that this Chateaubriand was produced by Neanderthals. This little tree that you see at the bottom shows you also something else, is that after these hominins were identified as, after these fragments were identified as fragments of hominins, and identified as Neanderthals by their mitochondrial DNA, Frido Welker, who conducted this study, was able to show that looking at some substitutions along the amino acid chain on different types of collagen, it was not only possible to show they were hominins, but they were Neanderthals. And this is something he will explain with more detail this afternoon. It's something which is quite important because it opens a possibility to identify a group of hominins not only by ancient DNA, but by ancient proteins. And as you know, DNA degrades through time, depending on physical conditions, in particular temperature. And as a result, all the ancient DNA that we have for time periods which are interesting to our question is ancient DNA coming from the middle to higher latitudes. and we have almost nothing from the tropical areas, which of course is quite problematic because we think tropical areas are likely the core of the demographic and evolutionary core of hominins, and where our species originate and diversified before expanding in the margins, for which we have a much more detailed record. So really paleoproteomics opened the possibility to go deeper in time and to go into the molecular phylogeny of groups living in areas where ancient DNA does not survive too long. So my second example is an example of early Homo sapiens. And these early Homo sapiens that we have identified in one site of, in Bulgaria are associated to an assemblage that is called initial Upper Paleolithic. It has been identified in the Levant, in Lebanon, in Israel, in Syria, in Jordan, but it's also known in Eastern Europe and in the Far East as far as Mongolia. You see here a number of sites which are assigned to this initial Upper Paleolithic. Why we are interested in this initial Upper Paleolithic? Because it predates many of these transitional assemblages that I showed you. And in terms of technology, it represents a mix of techniques coming from the middle and the Upper Paleolithic for the blade production. And because of the timing of these sites, many people have thought that initial Upper Paleolithic could be the proxy, the marker for the expansion of modern Homo sapiens in the mid-latitudes of Eurasia. And so we have focused on this red spot here in Bulgaria, a site called Bachokiro. Bachokiro cave has been already excavated in particular in the 70s by a group of Polish archaeologists. And reopening the site some years ago, we are very happy to see that there were still in situ layers. And in particular, this very dark layer at the bottom of the stratigraphy that yields a very rich initial Upper Paleolithic assemblage, something looking very much like the initial Upper Paleolithic found in the Near East. And because the site has a very good preservation of organic material, it has been possible to produce a large number of radiocarbon dates, and which is not always the case for the sites yielding initial Upper Paleolithic. And in Bachokiro cave, we are able to show that this dark layer that I showed you and the top of the layer immediately underneath yielded dates between, say, 43 and 46,000 before the present, which is much older than most of these transitional assemblages that I showed in my first slide. And importantly, by using, again, zooms on more than 1,200 little fragments of bones coming from this dark layer, it has been possible to identify a series of bone fragments which are humans. Again, these are not nice specimens that you would like to show in a museum, but they yield a wealth of information. First of all, it has been possible to date them directly. So we have a set of dates, direct dates covering this range of time between about 43 and 46,000. And it has been possible to extract mitochondrial DNA and actually also nuclear DNA, which is currently being studied and not yet published, so I will concentrate on the mitochondrial DNA. But the mitochondrial DNA is quite interesting. It connects these individuals with the roots of 3 major haplogroups, micro haplogroups, which are represented outside of Africa, M, N, and R, and they, when this mitochondrial DNA is analyzed, it showed that these individuals are really at the I would say, at the root of these major haplogroups. Interestingly, haplogroup M is not represented in Europe today, and if you want to find representative of these groups, you have to go to Japan or places like that. So it's really an Asian macro haplogroup. All the information that we have coming from these individuals and some other fossils of this time period suggest, in fact, that these initial upper Paleolithic makers are, of course, are early Homo sapiens moving in the mid-latitudes in Europe 46,000 years ago. So rather, I would say, soon after this major out of Africa movement that we set around 50,000. But in the meantime, they seem to be not connected to later Upper Paleolithic people. People which are found in the, I would say, in the real Upper Paleolithic, like Aurignacian assemblages. And so it gives a picture of this peopling of Eurasia by modern Homo sapiens, which is much more complicated than what we thought before. And the discoveries in Bachokiro have many implications. First of all, if you remember the dates I gave you for the Chateaubriand, the latest Chateaubriand sites in Europe are around 39,000. So it means that not locally, of course, but at the scale of the continent, we might have had an overlap of maybe 6,000 years, 7,000 years. So it's a very long time. It's a very long time for all sorts of interactions between these groups. I mentioned already biological interaction with this possible hybridization of population. But there is something else which is quite striking, is that with the initial Upper Paleolithic of Bachokiro Cave, we have these very nice pendants on the left here made of cave bear teeth, which are very similar to objects that are found in the Chateaubriand with the last Neanderthals a couple of centuries later in Western Europe. And this implies, from my point of view, something which I think is not very surprising, is that together with biological interaction, there were also cultural diffusion from one group to another. One implication also that's really important to keep in mind is that the story of this peopling of Eurasia by modern Homo sapiens is probably something much more complicated than what we thought. Maybe several ways which are not really connected one with the other, with replacement of the first wave by later waves. And finally, I would like you to also remember that this frustration that we have when we look at all the archaeological assemblages from this time period, this lack of fossils that make it so difficult to give a scenario of what's going on, may come to an end with the development of molecular techniques. Because, in fact, the fact that looking just at 5 sites allowed us to generate these results implies that if we would not look at just 4 or 5 sites, but if we would look at 50 sites from this time period, all these sites producing a lot of these little bone fragments, I think we will probably be able to obtain much more information, detailed information about this mechanism of replacement. Thank you very much.